You know that feeling?
Yeah.
When you're super focused on something, maybe trying to pull a memory and everything else just kind of fades out. Or like you get that really strong gut feeling about a situation way before your logical brain catches up.
Oh, definitely. Happens all the time.
Our brains are these amazing things, right?
Yeah.
Constantly trying to make sense of, well, everything. Chaos. But how do they actually do it? And what if the way they're built actually shapes what we think is real?
That's the core question, isn't it?
So today, we're really diving deep into that. We're looking at how our brains, especially the so-called rational mind, seems hardwired to split things up, categorize everything, creating this sort of binary view.
Yeah.
And this has some pretty huge implications for, how we understand science, how we think about knowledge, maybe even what absolute truth could possibly mean.
It's a really fascinating path to go down. And for this deep dive, we're leaning quite a bit on J. Alfred's work. He wrote a book, Brains and Realities, that's super insightful. Yeah, and he came up with this term, Hegelian cycles. He uses it to talk about how knowledge seems to evolve in these specific patterns.
Okay.
And his argument is that these patterns, these cycles, they actually reflect the basic ways our own brains work, the fundamental operations.
Interesting.
So our mission today, for you listening, is to kind of unpack the built-in filters in your own mind.
Your mental software, almost.
Exactly. Yeah. How do these filters shape what you perceive as reality, and what does that mean for how we learn things, how we gain knowledge, especially in science? We want to get past just information overload and hopefully reach a deeper understanding.
Okay, so let's start at the beginning then. How does information even get into the brain and get processed? I guess it's not always neat and tidy. Logic first.
Not at all, actually. It turns out our emotions often get the first crack at it.
Really?
Yeah. Joseph Ledoux, a neuroscientist, did some key work here. He found that sensory info comes in, hits the thalamus. Think of it like the brain's main switchboard. But then, crucially, it often skips the neocortex, that's our conscious reasoning part, and goes straight to the amygdala.
The amygdala.
Yeah.
It's deep in the emotional circuits, right? The limbic system.
Exactly. It's like our primal alarm system. It reacts first, often before we're even consciously aware of what's happening.
So our gut reaction literally gets a head start before our thinking brain can even analyze things.
That's a great way to put it. The amygdala acts as this initial, very fast binary splitter. It makes these quick, unconscious judgments, good, bad, approach, avoid.
Survival stuff.
Pure survival. Is it a threat? React. It triggers those automatic responses. It's a very basic, very fast filter.
Okay, wow. So that's layer one. And it sounds like this splitting thing, breaking stuff into opposites, it continues at higher levels too.
Oh, absolutely. It's fundamental.
Yeah.
Researchers Eugene DeKeely and Andrew Newberg, they identified another key binary splitter switch, but this one's in the neocortex, usually in the dominant hemisphere, often the left.
So in the thinking part of the brain now.
Right. And here's the really mind-bending part they found. This operator doesn't just recognize opposites that are already out there.
Yeah.
In a very real sense, it creates them. Think about concepts like heaven and hell, good and evil, life, death. These pairs, our brain constructs them to make sense of things.
Hang on. It creates them, not just labels them.
Yeah.
That's a big idea.
It is profound. This mental operator is crucial for how we perceive reality. It helps us order the world by dividing space and time into chunks we can grasp. Our experiences of pleasure, pain, right, wrong, they all kind of emerge from this comparison engine.
So one thing gets its meaning from its opposite.
Precisely. Like a bar magnet, You cut it in half, you still get a north and south pole, cut it again, same deal. They're inseparable parts of one thing. Like yin and yang, interdependent.
Okay. This idea of a fundamental split,
yeah,
it feels ancient. Is this something science just figured out, or did older traditions notice this too?
No, they absolutely noticed it. You look at Buddhism, Hinduism, they were talking about this tendency over 1,000 years ago.
Not kidding.
Yeah, texts like the Lankavatara Sutra, they talk about things being not two, but one, and sort of lament how we keep dividing things that are naturally whole. The Surangama Sutra says something similar about dividing things that by their nature are indivisible.
Wow.
And even in child development, researchers like Def Jennings observed that babies start with this kind of non-discriminating awareness. Why? Because their left brain, the categorizing part, develops a bit slower than the right.
Ah, interesting.
Discriminatory consciousness, the kind that sees everything in pairs, in opposites, it really kicks in as those oppositions start to form in the mind.
Okay, let's unpack this then. If our brains are constantly doing this splitting, categorizing,
Right.
what does that actually mean for what we perceive, like day to day? Are we missing stuff?
Well, in a lot of ways, yeah, we probably are. There are some classic experiments that show this really clearly. Nikos Logothetis and Jeffrey Schell, for example.
What did they find?
They showed people conflicting images in each eye, like lines moving up in one eye, lines moving down in the other, in the same spot.
Okay, what happened?
The brain can't fuse that into one coherent image. It's impossible, right? Two things moving opposite ways in the same space. So what happens is one image gets suppressed. You don't see both.
You only see one at a time.
Yeah, you perceive an oscillation. You see the upward lines, then the downward, then upward. It flips back and forth. One view is always canceled out.
So my brain isn't just passively receiving information. It's actively, like, editing my reality to make it make sense.
That's exactly the takeaway. It's called binocular rivalry. When the input to your two eyes is significantly different, your visual system just suppresses one feed to obtain coherence, as Bernard Bars put it.
Coherence is key then.
It seems to be. Bars said, conscious perception is always coherent, even if the nervous system needs to cancel some input in favor of another. So the brain is basically creating this apparently orderly world by, well, ignoring the messy bits, the contradictions, the blind spots.
This is where it gets really wild for just, like, everyday life. I mean, have you ever been so zoned in on something you just completely missed something else, something obvious?
That's the perfect example. It's called inattentional blindness. The most famous demonstration is probably that gorilla suit experiment by Daniel Simons.
Oh, yeah, the basketball one. I remember seeing that.
Right. People are told to count passes between players in white shirts. And while they're focused on that, someone in a full gorilla suit walks right through the middle of the game, thumps their chest, and walks off.
And people just don't see it.
About half the viewers completely miss the gorilla. They're totally blind to it, even though it's right there.
That's incredible. And terrifying, kind of.
It really shows the limits.
Yeah.
Simons and Matt McCormick concluded that this invisibility depends not on the limits of the eye, but on the limits of the mind. Our attention isn't just focusing, it's actively inhibiting other stuff. Focusing on one thing means tuning out other things.
So how does this affect us when we're trying to grasp complex ideas or even just juggle multiple thoughts? It sounds like we're fundamentally built for an either-or kind of experience, not both and.
That seems to be the case, according to Barr's work. It appears pretty much impossible for us humans to consciously hold two distinct interpretations of the same thing at the same time.
So we just switch back and forth really fast.
Exactly. We rapidly alternate. One activity, one interpretation is conscious, it's in the foreground. The other one recedes, becomes unconscious, background processing, like flipping a switch. Imagine if you could somehow consciously experience totally opposite sensations simultaneously, like hot and cold in the same spot. What would happen?
I have no idea. Static.
Well, your left brain, the one operating on that either-or logic, it would probably experience nothing. A cancellation, like adding +1 and -1.
It just zeroes out.
Right. But the right brain, which seems better at parallel processing, holding multiple things at once, might be able to perceive some kind of superposition of opposites. This might even be why the left brain historically dismissed the right brain's processing as unconscious. It couldn't grasp its non-binary way of working.
Is there any real-world example of this cancellation effect?
Actually, yeah. Think about Robert Monroe's HemiSync technology. It sends slightly different sound frequencies into each ear through headphones.
Okay.
You don't consciously hear both original frequencies. Instead, your brain perceives a third frequency, the difference between the two. It's called a binaural beat. It's like a subtractive combination.
Yeah.
The brain cancels parts of the input to create a single, coherent perception.
Wow. Okay, so we've gone from the basic emotional split to the conscious mind creating opposites, to how focus makes us blind. Now let's zoom out. How does this fundamental brain wiring play out on the really big stage like scientific discovery? What does it mean for how science actually progresses?
Well, it leads to this really powerful observation, often credited to people like Ron Cowan, referencing Andrew Strominger. Every major advance in our understanding of the nature of the universe has been preceded by a contradiction.
A contradiction, like two ideas that just don't fit together.
Exactly. Think back through history. There was that huge, fierce debate. Is light a particle or is it a wave? Both sides had really strong experimental evidence, but the two ideas seemed totally incompatible, mutually exclusive.
Right. So how did that get resolved? Did one side just eventually win?
Not quite. It took someone like Niels Bohr to come along with his principle of complementarity.
Complementarity.
Yeah, he basically said, look, reality is richer, more complex than any single one of our models can capture. Maybe light isn't either a particle or a wave. Maybe it's both, depending on how you look at it, how you measure it. Both perspectives are necessary, even though they seem contradictory.
So embracing the contradiction almost.
In a way, yes. And you see similar patterns elsewhere. Einstein had to reconcile Maxwell's equations about electromagnetism with Newtonian gravity. They didn't play nice together. Quantum field theory emerged from trying to reconcile quantum mechanics and special relativity. These huge breakthroughs often come from grappling with two powerful but seemingly incompatible truths.
This whole cycle, it sounds a lot like those Hegelian cycles J. Alfred talks about. Can you maybe walk us through that cycle in like simple terms?
Absolutely. It's a useful model. Think of it like this. You start with a thesis. That's your established theory, the accepted wisdom. Maybe it's strongly championed by the logical left brain way of thinking.
Okay, the status quo.
Right. Then, inevitably, new evidence pops up or someone looks at things differently and you get an antithesis. This is the opposing view, the challenger. It contradicts the thesis.
And I guess the establishment doesn't like that much.
Often not. Alfred talks about cognitive rivalry, our tendency to kind of suppress or ignore the challenging idea because we prefer the familiar one. The brain resists the conflict.
But it doesn't stay suppressed forever.
No. If the antithesis has merit, it keeps pushing.
Yeah.
And the real breakthrough, the magic moment, often happens in what Alfred calls the appositional superposed state.
Appositional, meaning side by side.
Sort of. It's that moment of insight, maybe more associated with the holistic right brain, where you suddenly see how both the thesis and the antithesis can be true, or at least valid perspectives on a deeper reality. It's like holding both in your mind as complementary. Thomas Kuhn called these moments paradigmatic shifts.
Ah, okay. The big aha moment.
Exactly. And that insight allows for the final stage, the transthesis. This is a new, higher-level theory. It doesn't just average the old ideas, it transcends them. It reconciles the original conflict by providing a broader framework where both the thesis and antithesis make sense as like limiting cases or specific aspects of this new, bigger picture.
So it's not just picking a winner or compromising, it's genuinely moving to a new level of understanding.
Yes, the idea.
Like the light example. Wave is the thesis, particle is the antithesis.
Right, complementarity is that appositional insight.
And then the transthesis is our modern quantum description, maybe thinking of wavicles or quantum field, something that embraces both natures.
Precisely. That's a perfect illustration of the cycle. And you can argue we're seeing this tension right now between quantum physics and general relativity. They're both incredibly successful theories in their own domains.
They don't fit together.
They fundamentally clash. So the search for quantum gravity or string theory or whatever comes next, that's the search for the next transthesis, the next big reconciliation.
Science has always had this ambition, though, right? The dream of a theory of everything. One single equation or framework that explains it all. Given these cycles, given the brain's binary nature, is that dream even possible? Or is it kind of chasing a mirage?
That's a huge and maybe humbling question. There's strong arguments, strong from people like cognitive scientist Donald Hoffman and mathematician Kurt Gödel.
Gödel's incompleteness theorems.
Exactly. They suggest that, actually, no. In principle, there cannot be a single, fixed, final theory of everything. Any powerful formal system, like mathematics used in physics, will always contain true statements that can't be proven within that system. Every theory rests on assumptions you can't prove from inside the theory itself.
You always have to assume something to start.
Right. Trying to prove those assumptions just pushes you to a new theory with new assumptions. It's turtles all the way down, in a sense. Hoffman puts it beautifully. The notion of truth transcends the notion of proof.
Wow.
So the implication is pretty stark. Science, especially because it relies so heavily on that left brain binary logical consciousness, might be inherently doomed to dualism. We'll always have these pairs of opposites, these apparent contradictions.
With only temporary breakthroughs.
With only occasional and brief reconciliations to monism, as Alfred puts it, maybe mediated by those right brain insights before the next duality emerges. There's an old quote from the Ramayana: "The world must suffer under the pairs of opposites forever."
That sounds bleak. But why? Why is this limitation seemingly baked into the system? Why can't we just eventually figure it all out?
The core issue seems to be the tool itself. Scientific theories rely heavily on mathematical frameworks. And mathematics, at least classical mathematics, is built on Boolean logic.
True or false, 1 or 0.
Exactly. The law of non-contradiction. Something cannot be both A and not A at the same time in the same respect. This excluded middle is fundamental. It inherently suppresses paradox, suppresses ambiguity, suppresses dissonant attributes.
Okay.
Think about that cone analogy again. You've got two observers stuck in 2D. One sees a triangle from the side, the other sees a circle from the bottom.
Right.
If you try to tell them, hey, it's actually both a triangle and a circle, from their limited 2D perspective, that sounds completely illogical. Impossible. They'd reject it.
Because their framework can't handle the higher dimension.
Exactly. They miss the 3D truth, the cone, because their logic forces an either-or choice. Lawrence Krauss, the physicist, talked about this kind of depressing realization, that the ultimate description of reality might just not be findable, even in principle.
And it's because of math itself.
He argued it's built into the nature of mathematics, this fundamental limitation.
Goodness. That's a lot to take in. If our perception, our logic, even our scientific models are all shaped by this binary either-or structure, how do we even begin to grasp a reality that might be more complex, more unified than that?
Well, it maybe forces us to shift how we think about knowledge itself. You can use that geometric analogy again. A thesis is like a 1D line, just length.
Okay.
Its antithesis adds a second dimension, breadth, making a 2D square.
Right.
The transthesis then adds a third dimension, height, orthogonal to that square, creating a 3D cube. It encompasses the lower dimensions but adds something new.
So each step adds complexity, new perspective.
Exactly, and you could argue that for much of the last 500 years, science often had a kind of one-dimensional view, insisting there must be one single ultimate theory. Paul Davies talked about that unsatisfying feeling of having two amazing theories, like quantum mechanics and general relativity, when the goal was always just one.
So is the takeaway that science is flawed? Or is it just growing up, maturing into a more nuanced way of seeing?
I think it's definitely a maturation. We're seeing a real shift, a movement towards what some call appositional science. Physicists like Lee Smolin, Tom Siegfried, Qumran Vafa, they're increasingly comfortable with this idea of duality.
Duality meaning
Yeah.
accepting the opposites.
Accepting that there can be two or even more seemingly different mathematical descriptions of the same physical reality, and they can all be equally valid. Which one you use just depends on your viewpoint, your frame of reference, the scale you're looking at.
Like one theory describes it this way, another describes it that way, and they're both true.
Exactly. A classic example is how certain five-dimensional string theories turn out to be mathematically equivalent to four-dimensional quantum field theories. They look totally different, but they describe the same underlying thing. It really echoes Niels Bohr again. The opposite of a great truth is also true.
That's a radical shift from wanting one single answer.
It is. And it connects to what physicist David Bohm was advocating 4 years ago, changing the whole orientation of physics. Instead of starting with the parts and trying to board up, maybe we should start with the whole, with a more holistic view first.
And this isn't just happening in physics, right? You mentioned even mathematics is becoming more pluralistic.
Absolutely. Sylvia Jonas, who thinks a lot about the philosophy of math, talks at math itself moving towards a robustly pluralistic picture. The idea that for many big open mathematical questions, there might not be one single unique, correct answer waiting to be found.
What? A multiverse of answers.
Kind of. A multiverse of mathematical universes, as she puts it. Different consistent systems might yield different answers. She even quipped that maybe only kids today would take seriously a unique theory of everything.
Huh.
And this connects to abstract thinking. Math, at its core, isn't really about things. It's about relationships, patterns, structures. Abstract thought like this seems to involve the right brain, more spatial reasoning, metaphor, analogy. It allows for a wider, more diffused kind of attention compared to the left brain's focused, concrete, step-by-step logic.
So abstract thinking is like a bridge.
It could be a bridge between that dualistic concrete thinking, this or that, and a more intuitive, perhaps unitary way of knowing, where things and relationships are represented by a unitary whatever. It's hard to even put words to it.
This whole conversation, the dualistic world being maybe illusory, the search for a deeper unity, the limits of logic, it really resonates with ideas from, well, ancient mysticism, doesn't it?
It absolutely does. You look at the Vedic scriptures from India and they talk about Maya.
Maya, the illusion.
Right. But it's often described more specifically as the fundamental law or principle governing the physical world, the principle of relativity and duality. In that view, the ultimate reality, God or Brahman, is absolute unity, oneness. Maya is the veil that makes that unity appear as this world of opposites, of separation, of change.
So the divisions we perceive are part of the illusion.
According to that tradition, yes. Paramahansa Yogananda, who brought a lot of these ideas to the West, explained it by saying that physical science, because it operates within the realm of Maya under its laws of duality,
It can't escape it.
it cannot formulate laws outside of Maya. Therefore, science will likely remain in a permanent flux, unable to reach finality. It will just keep probing different aspects of an infinitude that is ultimately inexhaustible.
It sounds a bit like that line from Ecclesiastes in the Bible. Vanity of vanities, all is vanity, there is nothing new under the sun. That feeling of endless cycles.
Exactly, that sense of cyclical madness, the endless dance of polarity. These traditions suggest it points to a fundamental limitation in how we normally perceive reality through the rational, dividing mind.
So, if our rational minds, our scientific methods, are kind of stuck in this loop of duality,
Yeah.
where does that leave us? Is there any hope for accessing that deeper unity or having genuine breakthroughs?
Well, this is where intuition becomes incredibly important. Think about how scientific breakthroughs actually happen. Often, it's not purely logical deduction. It's a flash of insight, a sudden connection, a holistic understanding that seems to come out of nowhere.
The aha moment again.
Right, and that kind of processing is often associated with the right brain's more holistic, intuitive functions. Even Bertrand Russell, a logician, admitted this. He said something like, "Reason is a harmonizing, controlling force rather than a creative one. Even in the most purely logical realm, it is insight that first arrives at what is new."
So reason organizes and checks, but insight creates.
That's the idea. Mathematics, logic, scientific models, they can point towards reality, they can describe its patterns beautifully, but they don't let you experience that reality directly, in its wholeness, that direct experience, that intuitive grasp of unity. Perhaps that's a potential of the right brain, accessible when the constant chatter and division of the left brain quiets down.
Wow.
Yeah.
Okay. So we've really gone on a journey here. From the most basic, almost primal binary splits in our emotional brain, through how our conscious, rational mind actively constructs opposites to make sense of things,
Yeah.
to seeing how the same pattern plays out in the grand cycles of scientific discovery,
Yeah.
the thesis and
Kind
antithesis,
of like Hegelian cycles.
and landing on this pretty profound realization that maybe the absolute unified truth we often seek is something that inherently transcends any single theory or framework our binary minds can fully capture.
It's a big shift in perspective, isn't it? But
Yeah.
what's so fascinating, I think, is that understanding these limitations isn't about, giving up on knowledge or becoming anti-science. Not at all. It's more about gaining a more sophisticated, maybe more humble, but ultimately more powerful way of engaging with information, with reality itself. It's like realizing you've been looking through slightly warped spectacles, as Kant might have said, or understanding the user interface isn't the underlying reality, as Hoffman suggests.
Recognizing the tools and their limits.
Exactly. And that awareness itself is a deeper kind of knowing. It helps you navigate the world of ideas much more effectively.
So let me leave you, the listener, with this thought then. If all scientific knowledge, powerful as it is, might be ultimately empty of absolute final truth, yet it's constantly refining our relative understanding, getting better and better approximations. What does that mean for how you define knowing in your own life? Maybe the deepest dive isn't really about finding that one single final answer anymore. Maybe it's more about continually questioning the nature of the questions themselves, embracing the infinite journey of discovery, rather than fixating on an elusive, perhaps impossible destination.